Welcome back! Today I've got an exciting tutorial for you. In this video we will first program an Arduino to continuously read values from one or more sensors. Then we will transfer this data to a CSV file on the computer and you will see just how simple this can be done using Modbus. It really doesn't get much simpler. And all this can be done with only a few lines of handwritten code, so let's get started. For this demo, we will be reading temperature values from a sensor using a normal Arduino Uno. This technique will actually allow you to both read and write to the Arduino, but the focus today is saving data to a file. When I hooked up the circuit, I actually ended up using a potentiometer instead of a thermometer. I will be using this to simulate a temperature. Let's take a look at how this simulated temperature finds its way to the computer hard drive. The sensor is connected to an analog input pin on the Arduino, and the Arduino will read the voltage on the pin continuously. After a value is read, it is placed in something called a holding register. The holding register is a list of values that we can read or write to. In this example, the value will be written to index number 1. Everything stored in the holding register will be available from the computer over the Modbus protocol. The Modbus library we will be using is called Modbus RTU slave, and it will handle all this behind the scenes. On the computer side, we need a Modbus client. The client will send a request to the Arduino, and the Arduino will in this case respond by sending a value back. For the client, we will be using a program called bvmodbus. In bvmodbus, we will configure a fixed poll rate and enable a function that saves all the received data to a CSV file. This approach comes with several advantages. Number 1 is that you don't have to focus on what is sent over the serial connection. This is handled for you. It's also a fast and efficient data transmission because Modbus uses very few bytes to send its data. Another advantage is that it is supported by many libraries and programs. You can, for example, read values from a smart home system like Home Assistant. This also works on both serial connections and on computer networks. Now we are ready to program the Arduino. First, we will open the Arduino IDE and install the library Modbus RTU slave. We then go to the top of the sketch and include the library. Next, we will declare an instance and initialize it with the serial variable. This is the serial port we will be using to communicate with the Modbus slave. Then we will declare an array of 16-bit integers, and this is our holding register. This is where we will put our data and the computer will read from this array. Inside the setup function, we will give the holding register to the Modbus slave object, and we will then start it with a baud rate of 38,400. To fill the holding register with some real data, we will fill the holding register with the index 0 with the data read from the analog pin A0. This will be done inside a loop function, so it will be read continuously. We can also, for fun, add some more data. In register 1, we will add the current time on the Arduino, and we will also add a sine wave to have something interesting to look at. Since the sine wave is stored as a float variable, I have made a special function that can handle special data types. Finally, we have to call the poll function of the Modbus slave, and this allows the slave to handle incoming requests continuously. That's it. Now we just have to download the program to the Arduino, and we are ready to test it. To be able to talk to the Arduino, we need a program that acts as a Modbus client. To download the program, you have to navigate to the GitHub webpage. On GitHub, you can search for bvmodbus_client, and you will see the repository. Inside the repository, you can scroll down to the latest release, and on the release page, you will find a download link to the exe file. When you are downloading the file, your browser will not recognize this exe file, and it will ask you if you trust the file. I have programmed this myself, so I know this can be trusted, and you can also check the source code on GitHub if you are unsure. So here you can press keep. When you have downloaded the file, you can double click it to open it, and here you also might get a question if you trust the file. But here you can also press accept. This is what the program looks like. We can now configure a connection to the Arduino by clicking on the red connection status indicator up in the right corner. The first option you get allows you to choose between Modbus RTU or Modbus TCP. We will be using Modbus RTU since we are using a serial connection. We then have to select the port where we have connected the Arduino, and we have to specify the baud rate we used in the Arduino program, 38,400. The three last fields are usually correct, so now we can press connect. The connection status indicator has now turned green, so we are ready to read and write from the Arduino. You do this by clicking on the white plus sign and select the holding register option. This will add a new command to the left list, and we can set it up to read from the correct registers. In the holding registers on the Arduino, we placed the analog measurement in the first register, and we also placed some data in number 2, 3, and 4. This means that we have to read in total 4 registers, and we will write that into the field called number of registers. The slave address can be left as default, and the start address can be set to 0. It's 0 because the program always starts counting from 0. That's all the configuration we need, and we can now press read. You see that the data immediately appears in the preview field on the left side and in the data table in the right. As you might notice, the values you see does actually not make very much sense. And that's because the Arduino uses the opposite order of the bytes inside the microcontroller, so we have to swap the order. You do that by checking the swap bytes and swap registers checkboxes. Now we see that the first register value makes more sense. I expect a value here between 0 and 1024 because that's the range for the analog input pin on the Arduino, so this makes sense. The next value also looks good because that's the clock on the Arduino. However, there's something wrong with the 2 last registers. What we have to do is change the data type of the registers, because on the Arduino side the data type is float, so we have to change the type to float in our program as well to display the value correctly. For convenience, we can give names to the registers to help us remember what kind of data the registers actually contain. Now we can enable polling on the values to make the program automatically ask the Arduino for the updated values every second. We can navigate over to the trend line tab, and here we can filter out the third register with the sine wave, and you see that we are receiving the sine wave correctly. We can also increase the poll rate a bit to get a smoother wave. Now let's instead filter out the sensor value. You see that when I move the potentiometer to the left, the value is decreasing and it stops at 0. When I move it to the right, it's increasing and gets a maximum value of 1023. This means that we are receiving data correctly, because 1023 is the maximum value that the analog reading function inside the Arduino can return. Now that everything is working correctly, we are ready to store data to a file. Let's move over to the poll settings tab. Here we have a section called Log to File. In the text box called Poll Data, we see the 3 values that we are polling. The way the data appear in this field is also how it will look in the log file. You can put quotes on if you want to, and you can also choose what kind of separator character you want between the values. Here I use the tab character because it works nicely with Excel. Next we have to specify where we want to store the file. You can press the button and choose a location. Now, the only thing that remains is to check the checkbox called Append to File. When you check it, the file will automatically be generated and the data will start flowing in line by line. You can also see that it appears in the file browser here. Now that we are logging, we can move over to the trend line tab, and I can use my finger and move the potentiometer to make a trend line that we can easily recognize later. I will move it up a bit and try to make a staircase stepping downwards, like this. We can now stop the logging and take a look at the file. When we open it in Notepad, we see that it has 4 columns. The first one is the timestamp of the line. The second column shows the sensor value. Then we have the clock on the Arduino, and then the sine wave value in the end. Now we can press Ctrl A and Ctrl C to copy all the data, and we can open Excel and paste the data there. Let's scale the column correctly. We can now select all the data for the sensor column, and we can insert a line chart. Now this pops up, and we see that this looks exactly like the plot we had in the program before. So this means that we have successfully created a log file that contains the data for the position of the potentiometer. We can also take a look at the second column. This chart is constantly moving upwards until it suddenly jumps down and starts moving up from there. This is what the Arduino clock does, so this is also correct. Now that we have configured bvmodbus correctly, we can save all the program settings to a file. This lets us restore the program state at a later time. Now I've covered the complete process from reading data, sending it over Modbus and storing it on the computer. To try this out for yourself at home, the only thing you need is an Arduino. Any Arduino type will work. And you will find a link to the bvmodbus program and the Arduino program in the description. Also, let me know if you are aware of any other Modbus libraries or programs that you recommend. I can also add some functionalities to the bvmodbus program if I get some suggestions. So I hope this was useful. Thank you.